Everyone, I welcome you to another session of a tutorial. My name is Hampe Kliman, the mentor, and of course I'll be running you through measurement and uncertainty practice questions. If you are new to this channel, consider subscribing, hitting the like button, and don't forget to share to others. If you've got a question, ensure you inbox me on the WhatsApp number projected on the screen. And of course, if you are lagging behind, ensure you register for personal tuitions. We have an interesting question where we've been asked to add the following measurements and report. We add the following questions and report. Okay, and then we report saying we add the following measurements and report the sum with correct number of significant and uncertainty. So look, okay, let's do solution. This question is very simple. They want you to add, okay, let's add 12.52 plus or minus 0.5 centimeters. Then you add it to 3.4 is a 0 plus or minus, this is going to be 0.2. This is 0 centimeters. And then the last one, you get 0.123 plus or minus 0.001 centimeters. Because you are adding, you are going to add all the figures. Now, we've got what we call the true measure, which is this measure here. Then this is the measure of error. True measure, measure of error. True measure, measure of error. The rules are add the true measures alone. So we say 12.52 plus 3.4 plus 0.123. We are going to get 16.04 plus or minus. Then you add the measure of errors alone, plus 0.2 plus 0.001. We are going to get a 0.25. Okay, like that. Now, notice how many significant figures we have. Okay, so of course there's a 1. So we've got 1, 2, 3 significant figures. On the other end, we also have 3 significant figures. So this is going to be centimeters. And this depicts the final answer. So that is how you calculate for this particular question. It's actually very simple. We come to the second question. They said for a volume V, okay, if V is equal to 4 over 3 pi r cubed of a sphere, then if the radius is a 5.0 centimeters plus or minus 0.05 centimeters, calculate the volume at its relative and absolute uncertainty using propagation of error rules. So, how do you solve this one? You say solution. Now, the volume of a sphere is 4.3 pi r cubed. We've been given the radius to be, let me write it as my data. The radius is 5.0 centimeter plus or minus 0.05 centimeters. The first thing we've been asked is to calculate the volume. So to calculate the volume, we are going to say 4 over 3 where there is pi is same as 3.142, then we get our radius. You always use the true measure. cubed. So what are you going to get? 4 over 3, then 3.142, 5 cubed. You're going to get a 523.6 centimeter cubed. Now, how do you find the absolute uncertainty? To find the absolute uncertainty, first of all, you need to find the percentage uncertainty. I taught this under personal tuitions, and I'm sure if you're part, you understand what percentage uncertainty is. Percentage uncertainty is equal to measure of error over true measure multiplied by 100. So 0.05 divided by 5 is going to give us 0.01 multiplied by 100%. We are going to get a 1%. This same 1%, this same percentage uncertainty, put it in rational form. So it will be 1 over 100. Then you multiply it with the volume which you found. Okay, so you're going to say 1 divided by 100 multiplied by 523.6. You are going to get a 5.236. Notice that the radius was feeding this power 3. The radius is feeding a power 3 or the cube, so you're going to multiply this by 3. You're going to get a 15.71. So absolute uncertainty is equal to the volume found plus or minus 15.71 centimeter cubed. That is how you find this particular question. If you found this video interesting and helpful, consider subscribing, hitting the like button, and don't forget to share to others. Thank you so much.